So, hello everyone. This is our third video of our OA series of dynamic programming, and this is a very interesting question. Let me explain you why. Firstly, let's try to read the question. And who are the people who are new to this channel? Please subscribe this channel because we are coming with very awesome content regarding online assessments, interview questions, resume and all, right? So if you are enthusiastic about coding, you should hit the subscribe button and like this video. So cool. And we will come up in this OA series. Almost every question would be hard, and it won't hard. We make it easy, and we'll learn a lot of concept from a particular single question. That's our main idea. Because what I figure out is people learn DSA, but they forgot they are not able to solve OA questions. That's why I came up with a new idea of teaching students after DSA what should they do, right? Now, interesting question. Count special integers. It's a lead code question. What did it say? A positive number, we call a positive integer special if all of its digits are distinct. Okay. Given a positive integer n, return the number of special integers that belong to the interval 1 to n. Okay. Means they should not be, all the digits should be distinct. Let's say this number won't be valid. Let's say this number won't be valid because 3 repeated 2 times, and this number will be valid because no digit is repeated. Also, there's one more constraint: the number should be smaller than n and greater than 1. Okay, that's particularly fine. Cool. Firstly, while looking to this question, the first intuition comes to our mind is checking the constraints. What's the constraint? N is till 1e9. Cool. Means we cannot apply some sort of recursion. That's it's not possible. Okay, that's choice gone off. Now what will we think? Well, generally n comes to n 1e9 times, right? Either we think of some O of 1 solution, or we think of some log n solution, or we think of some DP solutions. Cool. Whenever you see this kind of problem, right? When you get a 10 power 9 thing, some do thing we have to do with digits. And since you already know that in 10 power 9 there can be at max 10 digits. At max 10 digits, right? That means we can do something of over 10, right? Okay, that makes sense. That makes sense. But we obviously cannot iterate on all the number. One boot solution can comes to our mind is let's iterate over all the numbers and check whether it is special or not. That would be a O of n solution, and that won't suffice our answer. That's interesting. Then what do we do next? So I would explain you a very good concept, which is a digit DP concept in this video. And I will also walk you through the intuition why we are thinking in this direction. This is a digit DP thing. What does it say that? What kind of problem it covers? It covers certain kind of problems when you have to fill a number in a particular way. So obviously, how many indexes will be there? The size would be same as that size. At max could be there, right? It cannot be larger than. It could be smaller than that, but won't be larger than that. Okay, it won't be larger than that. So let's say there's number 5372, and we want to calculate for it. So let's consider for a very large number. Now, what possibilities this digit have? You can say it can have 0 to 9 possibility, and 0 will be discarded because the first number we are not considering as 0. Okay, we'll discard that position. Other than that, let's try to understand whether the first digit has some more constraint over these digits. Let's suppose the first digit fixed as 2. Is there any constraint on this digit? Like I'm considering the number should be smaller than this, then we are checking something. Obviously not, right? You can put anything between 1 to 9, anything between 1 to 9, anything of not 1 to 9, 0 to 9, 0 to 9, 0 to 9. There's no constraint. But. Let's suppose if it is 5, is there any constraint here? Yes, there is a constraint. It cannot be larger than 3. It cannot be larger than 3, right? Okay, okay. That makes sense. Means there is a constraint when I am keeping digits in a like the first digit. If I keep the max value, then there's some condition changes and some constraint changes. Okay, so let's try to think about what are the states we can maintain. We can think of, firstly, the obvious thing is position or index, whatever you can say. Let's say we are using position. Okay, the second thing I am saying, the condition that it is a tightly constrained or not. That's why we say a tight constraint, tight state, and its value would be 0 to 1, either 0 or 1. The position value will be 0 to whatever is the max size of the string version of that. Let's say max size. Okay, -1, you can say that. Max size is the size of the our number. In this case, 20, it is 2. Okay. And then what next? Now, how would you track that a particular digit was already taken or not? How do we check that? Either we maintain a set, but that's not a very good idea. How would we maintain in a DP state? And when you want to do this kind of stuff, what kind of thing in comes to your mind? Try to remember masking, right? Masking comes to your mind. Masking is there. Masking will help us. We'll see how it help us to track of. This is generally variable. This part is depends on the specific problem. Here we need a mask on specific problem. Other two things you can directly write will be always there. Like I'm not it's not always nothing a word, but like 90% if it's a DP problem on digits, it will be there. These are generic. Okay. This is also we got it. Fine. So we got three states. Let's try to understand the time complexities. Right. So pause max value could be at max 10. Yes. Tight, obviously we have only two states, so two. And mask is we will at each bit we'll say a particular digit is used or not. So we'll maintain, let's say at max how many digits we have to 0 to 2 power 9. At max there are 10 bits, 3 9 or 10. So max is at max 2 power 10, which is 1024. So if you multiply everything 10 into 2 into 2, that's how you calculate the time complexity and space complexity of a DP solution, right? Which is roughly of the order 10 power 4 into 2, which is bearable. It's perfect. The time complexity, the space complexity is perfect. Now let's try to understand the transitions and how would you go about that. Cool. Okay. What we'll do is we'll skip some states. Let's try to see let's see the base case first. Base cases v reaches the end of the index, right? Boss equals to our whatever you can say the size we have made, right? Let's say s dot size, and s is our two string version of our n what we were initially given with. Okay, s dot size. If we reach that, now we will check the whether our mask is 0 or 1. Return. It's a 0 or 1 only. It's a 0 1. Obviously, when we are counting things, we generally return 0 or 1. Mask is greater than equals to 1 or not. Or we can say greater than 0, should say directly. Mask greater than 0. What that does mean is if mask is 0, what does that imply? We have not taken any digit. That means the number is 0. That means we cannot consider it. We reach the end state. That means will have to find a valid solution or not. It will be valid only when the mask is greater than 0. We have taken some digit. Okay. Okay. This is the base case. And in counting problem, we generally do these kind of stuff. Okay. Then what we do next? We initialize the answer variable, right? At top of that, we run a loop, sort of these kind of things we do in some counting things. Now what we do, there are two cases. Firstly, if the type is set to 1, means what is that? The type is set to 1, the initial constraint is tied to 1. Then what will be the constraint? Let's try to see first. So what we will do is we'll run a loop. What is the possibility of that particular position then? Obviously from int I is equals to 0 to I less than equals to whatever is the our string that we are maintaining on that position minus 0, right? Let's say we are at 5 3 4 6 our n, and we are at position this, then and we are filling this position. So we have the constraint, right? We are at tight constraint. So we are assuming that previous also we have picked the tight thing again and again. Let's say 5 we picked and 3 we picked, then our let's say tight condition again we do, then our maximum value we can write here is at max 4, right? So this is how it is working. Okay, so for if the tight condition is 1 means we are picking the prefix part same. Okay, Okay, that's also fine. Now what we will do, we'll see two things. Firstly, let's check the particular digit we already used or not. How do we check that? We'll check in our mask whether the bit, the ith number is set or not. If mask and one left shift I is set, that means we'll do a continue. Why? This digit is already taken. We don't need to take it again, right? There's no case. So we won't find any answers from this state. Okay, we'll skip that. Skip it. Okay, we have skipped that. Let's move forward. What else? What else is there? Now there are more things remaining. Now we will check if, now obviously you also know that, right? We are filling in this case that the first index cannot be zero. We cannot put zero at the first index. So if I is equals to zero and then mask is also equals to zero, then what we'll do? Let's say we initialize our new mask. We'll see how we'll update our mask. So initially, let's keep our new mask as a mask only. Okay, we'll see what this mask do. So if this happens, we won't update our mask. New mask remains mask only. And if it is not the case, we'll consider this digit. And how do we consider this digit? It's very simple. Just set this digit means equals to mask or one left shift I. What we have done, if considered this digit, that's very very important. Okay, and if this happens, that means what? We're initially at the zeroth index and the mask is also zero, so we cannot consider that digit. Okay, that's also fine. Cool. Now now what happens? And now we'll consider the two cases. Basically, either we can pick this, so basically answer plus equals to, what would be the two possible solution? Either we'll pick this digit, right? uh, uh, right, so what happens, we are at solve heavy, right? So we have used position plus one. We'll move to next position. What's next other than that? Now also one more thing. Now will our digit will continue to be tight or not? Like we are at a tight position, let's say. Do we again go to tight? That depends on what, which digit we pick now. What that does mean is, let's say we are at 5342, and let's say this we already picked here. Now we are at this index. If we pick again 4, that means our tight constraint remain tight again. So we'll check if our s of position is minus 0 is equals to I. That means we picked our again the tight condition. Then we will do a answer plus equals to solve. What we'll do? Pos plus one. Obviously, we go to the next index. We will set the tight again. This is the tight constraint. And then mask is the new mask we already made. We'll update accordingly. And yes, we'll memorize it later. And else, not else, what we do? Answer plus equals to solve. Pos plus one. 0, right? We are not using the tight condition now. We have free to use any digit in the next state. Fine till here. Cool. Now what's the left? The else part is remaining, right? If tight is not 1, if tight equals to 0, if tight equals to 0. Now we have freedom. Now we have freedom to choose any digit. It's not like that you have to you go only S pos. We can go from 0 to 9. Now we have choice. Less than 9, I plus plus, right? We gone till here. And then again we'll check the same thing. What we'll check? If mask and one left shift I is set or not. If digit is used, continue it. We don't want to use it again. Other than that, we'll create the new mask again the same way, whatever we have created, right? same. Now here basically we have no constraint, right? Already we are relaxed. There is no if and else for tight or not. It will always be not tight, because once we are set to not tight, not tight. Let's say we have 5, 3, 4, 2, and we have set 5. Let's say we have set 2. Now there's no condition always, right? Beyond. Once we go to no tight state, it will be always no tight. So it would be pos plus 1, 0, and mask is new mask. Is that simple, right? So when you understand this problem, right, this conditions will change. This condition generally not change in a generic problem, but this was required, a particular digit should not be repeated. That we did that. Okay, let's try to see the code as well. It's a very simple code. We just use memorization as well. So what did we do? Firstly, we have created a particular other string of that, and then what we do? We do a size plus one, and then we created 3D DP to memorize it. That's all right. Okay. Then what we did? I explained you the same thing, right? What is this is our base case. When we hit s dot size, our particular sign, then if our mask is greater than equals to 1, we you can say that if our mask is greater than equals to 1, we will return a 1, and if it is equals to 0, means our mask is less than 1, that means we cannot consider this state. Then what we do, we return already our memory state. Now we consider our answer equals to 0. Now we have two cases: tight equals to 1 and tight not equals to 1. If tight equals to 1, that we have a particular, only a range is specified, right? If a digit is tight, okay, now we consider this, that okay, if this digit is already taken, we won't take it again. We created a new mask out of it. This is due to the first element not becoming 0. That's the case. We created the two mask, this to include this digit, include this digit. Okay, cool, that's also fine. And what's next then? And then we check the tight condition continues. Then what we will do, we'll again do that. If s of pos minus 0, if s of pos minus 0 is again our I, that means the tight case continues. We have to make it 1 again. Otherwise, we make it 0. And once the tight becomes 0, that means that always it will, we obviously this step is same, but this changes that we always have a not tight case, and this we sum of the answer. We memorize the solution using pos, tight, and mask, and this is our solution. So this is our easy solution. It's not very difficult to understand, right? I hope you understood the concept and entire intuition of our DP series. I will also post a good problem to practice for you guys. And if you have any confusion, do let me know in the comments. And if you like the video, please like the channel, like the video, and subscribe the channel. Right? Okay. See you in the next video. Bye bye.